Let's continue then by looking at a more detailed history of cellular and explore how cellular evolved from just an extension of the existing telephone system, simply extending voice services, to its near ubiquity, offering data nearly everywhere across the world. How old is cellular then? Historically speaking, the first commercial car-borne service was approved way back in 1946, with AT&T being the first one to offer commercial service. 1947 subsequently saw the introduction of cellular frequency reuse, which was not coined until cellular until the 1979 article that we talked about earlier. 1981 saw the rise of what was called NMT, or the Nordic Mobile Telephony Service, with AMPS, or Advanced Mobile Phone Service, coming in North America. Cellular phones at that time were still quite bulky, and perhaps several of you in the older generation might even remember the car bag phones of old. At its core, cellular service was just an extension of the phone network, and not a terribly great one at that. With the rise of digital services in the 1980s, new things were afoot. Cellular quality started to get better, transitioning from analog with its inherent noisiness into the digital realm with a much more consistent quality of service. Mobile devices started to become truly attractive as the footprint or size of the device began to shrink and costs began to reduce as phones gained in popularity. New data services emerged with the second generation of technologies, or what's called 2G. Not necessarily fast services, but with 2G came the advent of the first text messages, or what's called SMS, short message service. Early 2G systems afforded the blazing fast speed of 9.6 kilobits per second, or roughly 15 minutes to send a picture from your iPhone 5S. While that may not seem that fast, that was a veritable renaissance to think about the potential of what data everywhere might mean and how wireless technology was going to evolve. Not only were messages possible, but now email and the internet were but a few packets away if only we could move the data faster. However, getting there was going to be rough because there was not just one 2G technology, there were potentially 4 different technologies out there. GSM was dominant in Europe, IS-136 in Canada and the US, PDC in Japan, and IS-95A/CDMA in the US. Quite a mess, to say the least, but at the time, voice was still king, and we were still trying to figure out just how to bolt on data as an auxiliary service. Rather than jumping all into 3G, there was a brief stop off at what we called 2.5G, or 2.5G, with HSC, SD, and GPRS building on GSM, iMode on PDC, and I-95B CDMA. Is your head spinning yet? You would not be the first to get a bit confused at all the acronyms that we're tossing around. The key parts to remember, though, is that for many of these standards, it took years and lots of manpower, research and development just to get something that one can deploy. Hence, these splits were actually beginning many years prior and had been potentially even a decade in the making. 3G actually continued that trend, offering faster data, but still a firm split, with GSM growing out of 3 different data technologies, WCDMA, TS-CDMA, and eGPRS Edge, and IS-95 turning into CDMA 2000. Long story short, it was basically a major showdown between CDMA 2000, which was Qualcomm in the US, and the rest of the world with GSM. New technologies were eventually bolted on with HSPA, GSM, and EVDO, CDMA 2000 for the respective camps, now climbing up into the multi-megabit potential for peak speeds, with those speeds being dubbed 3.5G. Around that time, a new challenger came into the mix under the guise of a technology called WiMAX, trying to bring a best of breed of Wi-Fi and cellular together. Unfortunately, the experiences with WiMAX fell far short despite several high-profile attempts to bring it about. Now, with considerable manpower and resources having been invested in all of the various wireless technologies, folks eventually realized that perhaps continuing parallel development were not in the best interest of all the parties involved. Qualcomm eventually elected to not pursue the successor to CDMA 2000 and instead embraced the efforts of the standards body, 3GPP, that had led the GSM efforts. That new technology was called LTE, or long-term evolution. In fact, although we as the consumer frequently just see LTE advertised, there are actually multiple iterations, or what are known as releases, out of the 3GPP standards body. 3GPP Release 8 and Release 9 are the ones that actually introduced LTE and are technically known as 3.9G. 3GPP Release 10, which is coming out just right now, is what's known as LTE-A, or is actually the first true 4G as defined by the ITU, or International Telecommunications Union.